This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 6, Lesson 5, Codes and Standards. 4 ASHRAE standards shape HVAC design. 62.1 for ventilation, 90.1 for energy, 34 for refrigerant safety, and 15 for the refrigeration machinery room. The exam doesn't ask you to recite them, it asks which standard governs a decision, and whether you can use the handbook table it prints. Only 62.1 and 34 are actually reproduced, so we'll run a fresh ventilation calc, read a refrigerant safety class, and place 90.1 and 15 as recognition-only concepts. Concept: the frame. 4 ASHRAE standards shape everyday design. 62.1 governs ventilation and indoor air quality. How much outdoor air? 90.1 governs building energy, efficiency, the envelope, economizer limits. 34 sets refrigerant safety classes, toxicity, and flammability. 15 governs the refrigeration machinery room. Here's the key: only 62.1 and 34 are reproduced in the handbook, so those are the only 2 you can compute or read on exam day. That's the whole lesson. Codes tell you the target, and the handbook table gives you the number. Concept: the standards map. Fix each standard to its scope and to its handbook anchor. 62.1 governs ventilation, and its rate table plus the breathing zone formula are printed in the handbook. 34 sets the refrigerant safety class, printed as the safety group table. 90.1 governs building energy, envelope, efficiency, economizer and reheat limits, lighting, water heating, but it is not reproduced. 15 governs the refrigeration machinery room, ventilation, detection, relief, also not reproduced. The 2 printed rows are where all your exam day arithmetic lives. The bottom 2 are pure recognition. Setup: 62.1 ventilation, the week 4 recap. Here it's the code-derived number the exam makes you compute. The minimum outdoor air for a zone is 2 terms, always summed. The breathing zone rate equals a per-person rate times the zone population plus a per-area rate times the floor area. The 2 rates are looked up in the minimum ventilation rates table by occupancy category. Population and area come from the problem. This is breathing zone air. Week 4 then divides it by the distribution effectiveness to get the zone outdoor air. Solve: the classroom. 30 students in a 900 square foot room. The per person and per area rates come off the table. People term plus area term, 300 plus 108, 408 CFM. Drop either term and you underventilate. 62.1 prints 2 more tables the exam likes. Intake separation. An outdoor air intake keeps 30 feet from noxious exhaust, 25 from a truck dock or a cooling tower's exhaust, 15 from flues, garages, dumpsters or a cooling tower's intake, 5 from a driveway, and 1 foot from the roof below. And healthcare ventilation. Operating rooms run positive at 20 air changes. Infection isolation and autopsy rooms run negative at 12, with all air exhausted directly. The logic to remember is that positive pressure protects the clean room and negative pressure contains the dirty one. Solve: the refrigerant safety class, the week 3 recap. Week 3 built the class from the criteria. Here you only read it. The group is a letter for toxicity: A lower, B higher, split at an exposure limit of 400 parts per million, and a number for flammability, 1 for none, up to 3 for high, with the optional mildly flammable 2L. Find the refrigerant, read across. R32 is A2L, low toxicity and mildly flammable. Ammonia is B2, toxic and flammable. Letter and number are 2 independent, 1 comparison reads. Concept: the 2 you can't look up. 90.1 and 15 are not in the handbook, so you can't pull a value. You only need their scope. 90.1 is the building energy standard, envelope requirements, minimum equipment efficiencies, economizer and reheat limits, lighting power, and service water heating. 15 is the refrigeration safety code. It governs the machinery room, required ventilation, refrigerant detection, and pressure relief, all sized to the refrigerant safety class from standard 34. On the exam, these test recognition: which standard owns economizer limits, or a machinery room detector, never a computed number. 1 more printed pair: the building energy indices. EUI is the annual energy usage from all sources in common units divided by the building's total area. CUI is the same idea in dollars, annual energy cost over total area. EUI can be figured on site energy or source energy, and that distinction is a ready-made distractor. These are the yardsticks 90.1 compliance is measured with. Traps 4. 1. 90.1 and 15 are not in the handbook, so don't waste time hunting for a number you can't look up. Know that 90.1 owns energy and economizer limits, and 15 owns machinery room safety, and move on. 2. The breathing zone rate needs both terms. The per area term is separate from the per person term, and is often comparable, so people only or area only underventilates. 3. The safety class is 2 independent axes. The letter is toxicity, A the safer high limit group, and the number is flammability. A2L is flammable. Only class 1 is inert. 4. Codes set the target, the handbook gives the number. Know which standard governs, then use the one table it prints. Quick recall. 62.1 governs ventilation. Breathing zone air is the per person term plus the per area term, rates by category. 34 sets the refrigerant safety class, a toxicity letter, and a flammability number you read off the table. 90.1 governs building energy, and 15 the refrigeration machinery room, but neither is in the handbook. Golden rule, codes name the target, and only 62.1 and 34 give you a handbook table to compute or read. Next up, Lesson 6, Acoustics and Vibration Control. Codes told us the targets, now we design to noise and vibration limits. We'll cover acoustics, NC criteria, and the +3 dB rule for combining 2 equal sound sources. Then, vibration isolation, where the physics lives in Chapter 2. A bigger static deflection lowers the natural frequency and improves isolation. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.